The compmeansC function is one of the most powerful functions in the RCPA3 package, and we use it a lot in the book. The required arguments are fairly simple, but there are a lot of optional arguments and plot-related arguments which allow you to do a lot with compmeansC. In this video, I'm going to focus on the compmeansC function's optional arguments for controlled comparisons. I cover other uses of compmeansC, like making basic comparisons, generating basic plots, and hypothesis testing in separate videos. The compmeansC function has two required arguments. dv is set equal to the dependent variable, and iv is set equal to the independent variable. The compmeansC function supports a standard set of optional arguments. To make a controlled mean comparison, you set the function's z argument to the control variable. The function's zlabs argument lets you specify names for the z variable's values. Now about the plot-related arguments. I discussed the functions plot, main, xlab, ylab, and plot.ci arguments in the video on generating basic plots with compmeansC. Those arguments work the same way with plots for controlled mean comparisons. The functions z.palette and legend.title arguments, however, are only used when you're plotting controlled mean comparisons, so I will show how they work in this video. To learn how to use the compmeansC function to make controlled mean comparisons, let's work through some examples. I'm going to use the compmeansC function to make a controlled comparison and its plot-related arguments to display and visualize that controlled comparison. I've already installed the RCPA3's package and used the library command to load it into this session. I'm going to execute this help command I've commented out to have the help file accessible to us as we use the function. And in line 6 here, you can see I've already started with a basic call to compmeansC to make a comparison of the feeling thermometer toward journalists by 5 categories of education, and I've added a variable for the W argument, the variable to weight observations differently to make them more nationally representative. I'm going to start by executing the basic comparison, and then we'll add a control variable to this analysis. You've got our basic bar chart here of the means. This is similar to what we displayed and we talked about in the video on the basic use of the compmeansC function. So you can see how the feeling thermometer towards journalists varies by level of education, these 5 levels of education. Now you might say to yourself, well, I know that party identification has a relationship with education level and an apparent, say, general increase in the feeling toward journalists from education level may be really an effect of party identification, or controlling for party identification may make the education effect more clear. Not exactly sure what will happen ahead of time, but we can use the z argument to specify a control variable, such as party ID 3. A comment before I proceed further. Okay, so just want to make sure you realize the z argument is similar to dv and iv, except for it's for the control variable. Z is, use z because z is often like the other factor, not x or y, a z variable. So z is set equal to the control variable, the variable you want to control for in the analysis. And when you're doing a controlled mean comparison, generally the control variable will have very few categories. So 2 categories or 3 categories, possibly 4. The reason for that is on the table and on the plots, the number of values to be displayed or plotted is a product of the categories of the independent variable and the control variable. So this one has 5 categories of the independent variable and 3 categories of the control variable. So we're going to end up with 15 different means in the table. And then when it comes to plotting, we'd be trying to plot 15 different means. So there are, as you might know, there is a party ID 7 variable in the data set. And in some ways that's more fine-tuned control. But the problem with that is if we had 7 categories of the independent variable and 5 categories of the independent variable, we'd have 35 different means to plot, and then 35 means to try to fit into a figure. So try to keep that number low and manageable. I mean, you want to make a good control comparison, but you want to do something that's like workable and that will be revealing in the analysis. A bit of trial and error, but let's run this and see how it looks. Okay, we've got some output for a table and then a plot here. Now, on first impression, this looks kind of messy. You can see some like obvious issues with it, but in general, we're separate, like you can see on the plot, it separates respondents into 3 categories. Separate them first by the control variable, Democrats. It's not labeled here, but these would be independents in the middle, and then third is Republican, and then the bars within each cluster are the education level. And it's kind of interesting here, very interesting pattern where you see a increased feeling thermometer toward journalists with education among Democrats, looks fairly flat among independents, and then actually is declining among Republicans. So interesting results here, suggest sort of an interactive relationship. And now the table is going to get pretty funky pretty quickly, because what it's trying to show you, if you go back to the original mean comparison table, is trying to show you the means, ends, and standard deviation for within each value of the control variable. So it's trying to show you the mean, end, and standard deviation for Democrats, independents, as well as Republicans. So it's trying to get very wide, more wide than we really have the space available for. So we could lower the font and stretch out the window to see this more clearly, but an option you can use is this compact argument. This is why we made the compact argument. You can have the function display the table with means only and omit the n and the standard deviation. And this generally, for a controlled mean comparison, will help the table fit the space available and be more readable. It doesn't always work perfectly, but it looks better than it did before. But if I stretch this out, really mash up the plot or obscure the plot, sorry about that, but now you can see what it looks like or should look like. We're getting into options in a minute to help this table further and help the plot, but you can see what's going on here. It separates the respondents into the 3 categories. Those are the categories of our control variable: Democrat, Independent, and Republican. And then within each category is showing the mean value of the feeling thermometer towards journalists by level of education. And like I said, when you have 3 different control variable values and 5 different independent variable values, the table will display 15 values and tack on in the margin of the table 3 additional values for the totals. So becomes a lot to display. I think we're kind of at the frontier of the amount of information you might want to display in a controlled mean comparison table. Well, we probably make this more manageable so it won't look so wide and overwhelming, and we can improve it, but we're off to a really nice start.